Hello, the purpose of this video is to explain the variable statistical process control chart using the data that we collected in class. The data in front of you is the data from the 2 p.m. class. However, if you were in the 12:30 class, you can just as easily use that data. It doesn't really matter. So what you see in front of you, of course, is each of the tables 8 observations. So it's important to note here that the sample size for this problem is 8 because it consists of these 8 observations for each of the tables. So the first thing we want to do is create the sample average. So we'll go in this box right here. And I think the easiest way to do it is to go up top and go to auto sum, click on average, and it will default to that group of numbers. Now the other thing I think it's a good idea to do here is to add in the word round right here, R-O-U-N-D, open parentheses, and then you're going to put comma at the end with the number of decimal places, and for this we're going to use 2, so we'll put comma 2 and hit return. Now right now I've got it adjusted so you can't see any decimals, so I need to go up here and increase my decimal by 2. Now I've got the proper formula in here, round average over those cells, and so I can grab it and pull it down by grabbing right here and just pulling straight down to the last of the table observations. So what I have just computed is the mean for each table. So if you go down here to step 1, it says compute the average for each table. So that's exactly what I have done. We can write in here, this is essentially the same as adding each sample observation and dividing by the sample size. So in the case of just say table 10, just because I can see it, we would have 70 plus 50 plus 30 plus 60 plus 50 plus 40 plus 50 plus 70. We would sum all those numbers up, and then we would need to divide by n, and in this case n is equal to 8, and that would give us 52.50. I got all those numbers in there: 70, 50, 30, 60, 50, 40, 50, 40, 50, 70 divided by 8, yeah. So that you would need to do that for each of the tables here, and we just did it kind of all quickly with our sample average. The other thing we need to do here is the range. So we're going to do equals max, open parentheses, and highlight this, close parentheses, minus min, open parentheses, highlight the same thing again. Now, we could also just look at this and we could eyeball it and say, okay, the highest number is 80 and then the smallest number looks to be 30. But if you do it like this, you don't have to worry about missing something. And then we'll just pull it down again. Now we have all the basic computations necessary to create the X double bar. And remember, the X double bar is essentially the mean of the means. So here's all the means. And we're going to just take the average of that. So we'll just go back up there to that auto sum again, and we'll take average, and probably don't need to round this. It's not going to really matter. It does matter on the individual samples, but probably not here. It's not going to matter too much, I don't think, but we'll do it anyways just for thoroughness. So we've got our average, and we'll change our rounding up by 1. And then we can go ahead and compute our bar, and if we just pull this over, we'll get exactly the same formula with round and all of that already in it. It's just that it's pulled over for the relative formula over here. So let's go back down here to our step 2, and here we're going to be computing the mean of means. So we're going to do it the same exact way, right? We're going to add the means for each of the tables and divide by the number of tables, which in this case is 10, or 10 in this case. Let me just wrap this. The next thing we need to do is compute the standard deviation. And what we have here is ostensibly the population. It's not exactly a population, but for us it's sort of the population of observations. So we can go into this box, we can hit equals, and I know that the formula for standard deviation is STDEV for the whole population. So we're going to do dot P. You could also do dot S, just depends. But anyway, so we're going to highlight all of this. Oops, I didn't open my parentheses. We'll highlight all of these observations and we'll close up our parentheses and we should be good. We're going to go ahead and add in there the round command, just to be careful. We don't want it to be messed up. Now this is the standard deviation of our population, or essentially all of this, but because we have kind of a small n, I mean, I know it is 80 observations, but it is kind of small statistically speaking. We're going to need to divide it by the square root of our sample size. So we're going to open up a formula here where we take 15.522, so I just clicked on the box. We're going to divide by open parentheses SQRT open parentheses 8, because that's our sample size, and then we'll close up our parentheses for our denominator, and we'll go ahead and round that to 2 decimal places. So this is actually the number that we're going to use in our calculation for the upper and lower control limit. And the LCL calculation. Make that a little smaller so you can read it. And then the average range. Well, we've already computed that. That's right here. That's 39. So we'll just hit equals and hit that. And we've got that. So let's go down here. Compute the standard deviation of the population. So in this case, we're going to use this method I just showed you. STDEV.P, or you can use .S. It's not going to matter. Once you have the population standard deviation, which it has a special notation. So I just went ahead and wrote it out there. The population standard deviation is always denoted by this symbol here, and we're going to compute that. Compute the sample standard deviation by dividing through by the square root of the sample size, which in this case is 8. So our sample standard deviation will be 5.49. Okay, so now we're going to move on to the next step. And this step will be to compute the upper and the lower control limit. So when we compute the upper and the lower control limit, we need to use this formula I'm going to type out here. So I went ahead and typed out the whole formula there for you, and now all you have to do is find the value here, which will be computed as the upper control limit. And I'm going to go right out here and just calculate that real quick, because it's just easier to do it using Excel than using your calculator. So you're going to hit equal sign, or in my case I'm hitting plus, because that also will start out an equation. I can just go right up here and click on X double bar, go back to my equation, plus I need to open up my parentheses, hit 3 multiplied by the standard deviation of the sample standard deviation, that 5.49. We close up our parentheses and we ought to be set. Although I didn't round it, so let me just stick that in there. So this means that the highest we would want any of our table averages is to be about 72. So if we have a table that goes above that, then that would suggest that they were doing something that was maybe not quite the way it was supposed to be. And we're going to go about that the same exact thing to compute the lower control limit. So you can see I actually had to move this formula. It was here up here because I had put this one down here, but nonetheless they're all organized now. So the upper control limit is 71.79, or about 72. So if we had a bag that weighed more than 72 grams, then we had something that was odd. And then the lower control limit was 39.07. So if we had not just a bag, I misspoke before, if we have a set of bags, a whole table of bags, their average is below 39.07 or above 71.09, then we need to be a little bit concerned. So let's just quickly go up here and take a look and determine if our sample is in control. So what we're doing is we're looking to see if any of these numbers are below 39, which it doesn't look like they are, nor are any of them above the upper control limit of something in the 70s. I can't remember, what was it, 72. So it looks like they're all in control. Now let's go down here and create a graph that graphs these data. So what we have to do is we got to create 4 columns here. The first column, well, maybe it's 5, is the tables. Then we have the upper control limit, the lower control limit, the mean, which is really X double bar, and then the table averages. So we'll just go right up here and just grab all this. So we just highlight it and hit Control C, bring it down here, stick it right there, and then we got to go up here and get all these averages. So we're going to copy them the same way, Control C, but when we get down here we're going to do something a little bit different. We're going to go do our right click, and instead of choosing this, which we normally would do, which is just paste, we're going to choose this values, because in those in those values up higher, those are all computed values. So if we were to just copy it the way it was, it wouldn't actually work, because it's averaging the 6 numbers to the left of this number in the cell. So if we would have just copied it down, we would have got a bunch of number signs, which meant we did something wrong. So we had to copy just the values. For these, the upper control limit and the lower control limit, we can just grab this, equals copy, and then the lower control limit, same thing, and the mean we can also just grab from up here, or you can also just type it in, the X double bar. But now you have to highlight, copy, paste values only in order to be able to pull it down and have it work. Okay, now you've got this created, so you can easily create the graph. And the graph is nice because it allows you to sort of graphically see your data. You don't have to like eyeball it, so I kind of like that. So we just go like this. Actually, I don't know if it will let me merge those, so we'll just do it like this. And we're going to go to Insert, and right here insert a line chart, and we're going to pick this one here. Now you can see here, let me squeeze it down here so you can see the whole thing. You can see this is our upper control limit, this is our lower control limit. Here is our midpoint, the gray line there, and then you can see our observations that are kind of bouncing right around our midpoint. We don't have any observations that are out of the control limit, so therefore we could conclude that these data are in control. So does our sample appear to be in control? We want to say yes, the sample is in control because none of the table averages are outside the upper control limit or the lower control limit. Now for this last question, what might be the assignable causes of variation? So since we don't have any variation, well, you really don't have an answer. Now in the other class they did have some assignable causes of variation, but let's just go up here and look at this data and see if anything stands out to us. So a couple things to me are problematic. So this is one of them right here. Notice that all of these observations are like 50, 60, 50, 50, you know, they're all kind of the same. There isn't much variation in that sample. So that would strike me as odd. This one here has a very high sample, like almost twice the size of all these other ones. And this one has got this 90 and then it has these 30s. So that would suggest too much variation, whereas these would suggest too little variation. So because our X bar chart doesn't really pick up on that, we can do what's called a range chart and take a look to see if our range is okay. Because when we look at data, we look at the numeric variation, but we also want to look at the span of numbers, right? Because it looks like our sample is okay, but when you look at the range, you can see that our range varies, you know, quite a bit. I don't know if it is actually too much, but it is quite large. Okay, so I went ahead and graphed both sets of data so that you could see. So this is the one that we just did, and then I went through and did exactly everything the same over here for the other set of data. So this is the 12:30 popcorn candy graph, whereas this is the 2 p.m. popcorn candy graph. So I did that so that, you know, everybody could kind of check their work, but also on the 12:30 popcorn candy graph it's a little more interesting because you can see that this point right here and this point right here are outside of the upper and lower control limits, because this blue line here represents the upper control limit, this red line here represents the lower control limit, and these observations are outside of it. So we can go and check out what happened at table 5 and at table 9. So you can see here this is table 5, and then let's just go up above and take a look and see what that shows us. If we look here at table 5, we'll highlight this. We can see that all of their numbers are pretty darn low, right? I mean 32, 37, 37, 32, 32, 42. So something seems a little off there. By the same token, we had one group that was kind of high, and that was maybe this group here, table 9. And so if you look, you can see all of their observations were pretty high. Now remember, we only are really interested in this last value right here. We only use the sample average when we're determining whether or not the sample is in control. But so in the case of this problem, the 12:30 class, we would say in answer to question 1 and 2, we would say that no, the sample is not in control because table 5 is below the LCL and table 9 is above the UCL. What may be the causes of assignable variation? Well, there could be many from the class. Bad directions, it was hot in the room, they didn't have enough supplies, you know, just any of a variety of things. It could be poor training. The scales could be off. I mean, we could just go on and on because we didn't have a very scientific study. But you get the basic idea here. So that is what we went over in class on Tuesday. And we'll move on with the range charts for Thursday. And you should be able to do this same thing that we just did here with respect to the boxes on the handout that I gave you in class. And so be prepared to answer clicker questions on those, the same computations that we did here, and discuss that in a little bit more detail. All right, I hope this is helpful.